Hello, guys, and welcome back to another video on the AI series by We the Demigods Motivational. In this video, we are going to talk about three types of learning: supervised learning, unsupervised learning, and reinforced learning. We will also discuss some examples to help clear understanding of how and where to use these algorithms. In a supervised learning, we have inputs and output. We have an algorithm like y is equivalent to g bracket open x bracket close that transforms input into output. For supervised learning, inputs are often called predictors or independent variables, and output is called response or dependent variables. Here, machine learning optimizes the parameters such that the approximation error is minimized. That means our estimates are as close as possible to correct values given in the training set. Let's take an example of spam emails. As you are aware, there is an automatic spam detector that can filter out spam before clogging the user's mailbox. This is a real problem that was solved by machine learning. Developers used a set of 5,000 plus emails as sample data from internal email messages and classify them as genuine email or a spam. So the outcome class is just two classes. Either it was an email or it was a spam. This is again a classification problem. As this is supervised learning, we have both the inputs and the outputs. We have the database of email messages which are inputs and they are labeled according to as email or spam. We can use this information to train the output. Let's understand more on classification algorithm. In classification algorithm, you have an input, you have an algorithm, and your output is going to be a class. These algorithms are defined with the types of algorithm they produce. So in classification, you will have a qualitative output. Example, credit scoring. Bank predicts in advance the risk associated with a loan given the amount of credit and information about the customer. In this example of credit rating, first of all, we will set up a rule whether a customer is low risk or high risk. That is called discriminate. This is a function that separates the examples of different classes. Once we have the rule that fits the past data, we can make correct predictions for the novelists. Another place where we can use classification algorithm is pattern recognition. Some of the examples are character recognition, face recognition, medical diagnosis, speech recognition. Another use of classification algorithm is knowledgeable extraction. This means learning rules from data. Rule allows us to explain the data in much simpler manner. Once we have the rule extracted, we can use classification algorithm for compression. Storing all the data will need a lot of memory. Fitting rules to data gives the explanation that is simpler than the data, requiring less memory to store. Classification algorithm can also be used for outlier detection. Finding the rules helps us identify the exceptions. Let's now understand unsupervised learning. In unsupervised learning, we have no labeled responses. At any given point, we only have the input data to work with. We do not necessarily know what we are looking for, however, we have a goal. And that goal is to find the regulatories in the input. In statistics, this is called density emission, where the input space is structured. As a result, certain patterns occur more often than others. In machine learning, this is called clustering. aim is to find the cluster or groupings of the input. Let's take an example of customer data for a retail outlet or an investment company. Company would like to learn natural groupings of customers so that the company may decide strategies to target specific groups based on customer demographics or past transaction data. Let's now understand reinforcement learning or semi supervised learning. In reinforcement learning, we have our observations, which are the inputs. Output of the system is a sequence of action. Well, each individual action may not be important, but the policy or the sequence of correct action to reach the goal is what is important. Reinforced learning algorithm has a lot of interesting use cases. One of the most prominent example is playing a game. A move is good if it is part of a good game playing policy. Even though games are easy to describe by a set of rules, it is difficult to play. Like chess, we know all the rules of a chess game, though it is very difficult to win a chess game. Reinforced learning is a very important for both AI as well as ML. With this, we have reached the end of this session. I hope you enjoyed this video. Do like, share, and subscribe. Thank you for watching. See you soon.